Kim, can we please go live?
We are live.
Good afternoon, everyone. My name is Ntomfuthi Nduli. We are going to wait until everyone has joined. I see the numbers are still going up. As soon as the numbers stabilize, then we're going to start our program. Kim, I'll just wait for you to put up the slides before we can start with the program. Thank you, Kim. Good afternoon, everyone. Like I've said, my name is Ntomfuthi Nduli. I'm CEO of the South African Wind Energy Association. Welcome to the session for our Developing Developers webinar series. We've run 5 sessions up to so far, and this is our 6th one. And today we are focusing on commissioning projects, focusing on engineering, procurement, and construction. This is a webinar series that we started in September last year, and it's in partnership with the South African Wind Energy Association, the South African PV Industry Association, and sponsored by Mainstream Renewable Power and Juvi, who's our series sponsors. And our partners for the sessions is the IPP office, REEF, and the Black Energy Professionals Association. As we're going to kick off the program today, I would just like to take you through what the program looks like. We're going to take about 2 hours, hoping to stop promptly at 4 o'clock. And so we're gonna start with a presentation from Isaac van der Merwe from Robex, who's going to give us a presentation on wind energy projects. We're gonna go into the next presentation by Dylan Tudor Jones from Grand Solar Group, who's going to give us about EPC planning, implementation, and opportunities for solar PV projects. And then we'll go into understanding the construction challenges and hurdles experienced in executing solar and wind projects. And the presentation is going to be done by Matt Ash from Norton Rose Fulbright. And then our last presentation is going to focus on commissioning renewable energy projects, which is done by Simon Sanot from NL Green Power. And then at the end, we will have a Q&A session, which will be facilitated by my colleague, Niveshan Gavenda, who's the COO of SAPVIA. And then he will also conclude by giving us the closing remarks. So we've taken a lot of time in the beginning, and we do apologize for that, for the delayed start. Wanna kick in straight into our first presentation. Like I said, Isaac van der Merwe is a business unit manager, wind energy at Robex Infra. He's a professional engineer and he worked for Eskom for 13 years before joining the construction industry. And he's worked on more than 40 REEF projects at different stages of execution, and 15 of those projects were wind farms. So he is more than experienced to give us the process that's being followed in execution of wind energy projects during construction phase. So without further ado, I'll hand over to Isaac to kick off with his presentation. Thank you.
Ntombi, thank you very much. Good afternoon, everybody. Can we move to the next slide, please? Oh, next one, please, Kim. Okay, I think we can even skip this one. Just quickly, also a little bit of marketing. Sorry, Kim, just one back if you don't mind. Yes, I work for Robex Infra, but just a quick one on the Robex Group, fairly large construction company. I believe we're the second largest construction company in South Africa at the moment, consisting of three divisions, a materials division that sells product into the civil industry, then roads and earthworks that do the big and bulk works, built highways, that kind of thing. And then the infrastructure, the division that focuses on electricity, energy, housing projects. We do some rail, we do some telecoms, water, pipelines, etc. Next slide, please. Okay, then a little bit about Robex Infra. We consist of 4 different business units. I'm not going to focus too much on the others. This is for interest. If you want to just quickly read through it, or I believe the slides will be made available afterwards. Firstly, we also do some bulk earthworks and street construction. We do some roads for provincial roads, not the main SANRAL roads. We also do the civil and electrical infrastructure, civil and general infrastructure and large bore pipelines, for example, bulk sewer works, etc. We have a telecommunications and special projects business unit that do fiber and GSM. We install telecommunications tower. We do fiber to home, for example, and we also do other special building projects. And lastly, we have the electrical infrastructure and renewable energy business unit. We've been operating in both the private and REEP sphere since probably, I think, 2013 already. We've been involved in close to 15 PV projects to date. We've been involved in 3 wind farm projects. The first one, be it not part of REEP and also not extensively. But as Robex Infra, we're currently busy with the construction of two wind farms, one of them full EBOP and CBOP, and the other one just EBOP. And this is what I want to get to as well. One of the good things about Robex Infra for our customers is we actually offer the full balance of plant scope of work with the Eskom self-built works as well. In other words, we do the full electrical self-built works and balance of plant, as well as the full civil balance of plant works as well. And then we also do some electrical and distribution, electrical reticulation and distribution infrastructure for urban developments as well. Next slide, please. And now we jump right into the meat of things. I need to warn you up front. I may be making some controversial statements, but I felt that it might be necessary at this stage, simply so that everybody on both sides of the fence, and when I talk about the fence, I'm talking about client and I'm talking about contractor, so that everybody on both sides of the fence actually try and get a feel of what the other one's opinion is and view is, and the kind of challenges that people experience out there. So the first thing, and I've also split it into two, both the planning and the implementation phase, to look at some of the things that the developers are doing and should be doing, and then also what the EPC contractor are doing and should be doing. So firstly is developing a project on Google Earth. We know this is where it starts. This is the best resource we have to actually develop projects. So it's logically, it makes a lot of sense, but we have to, during the planning phase, eventually go to site as the developer, even during the writing of the employees' requirements and during the development phase, to actually get a much better feel for things on site. One of the things, and I'll get to a later picture as well that I want to show you as an example when it comes to environmental approvals, is the road width, and more specifically, not only the road, but also the environmentally authorized area within which the road and the V-drain for stormwater management, as well as the collector circuit cables are normally placed. That needs to be considered right from the beginning as part of your environmental process. Otherwise, you have massive problems during your construction phase. Next one is the fact that a desktop geotech is normally done during the development phase. And often it happens that the developer or IPP asks the contractor to quote on a desktop geotech. And that price is used eventually after negotiations to sign the contract. And now we get to site and we start with a real geotech, and then we find, oops, the desktop geotech wasn't all that accurate. And that's when things start to go south as well. Another one is typically the 132 kV overhead line route survey. That's also part of the environmental authorization process, but please involve a surveyor from the beginning, especially a surveyor with experience in finding 132 kV overhead line routes. The substation location and the size also, rather make provision for it, for example, a 200 by 200 meter space. And also, please don't put it on the slope of a mountain, on the side of the mountain, where you have, for example, 5 meter cut and 5 meter fill. It becomes very expensive and you have to build a retaining wall often. So, and this is also often a result of doing your development in Google Earth, because Google Earth is used right up front to find the location for your substation. And that's when your environmental process starts, and people don't go to site to go and then realize that, hey, we can't build a substation here. Another one is the transformer delivery route. Is also quite critical to make sure that you can actually get the transformer to site on the public roads, not only the wind farm roads, because that's what you will be designing and constructing naturally. Permits, there are sometimes misconceptions which permits the contractor should apply for, because often those permits can only be applied for by the developer. And I think I need to move slightly faster at this stage as well. I think I've got just too much to say. But anyway, choose the correct contractor is, I think, quite important, and that goes without saying. And during your planning phase, even before you start signing contracts, you have to spend an enormous amount of time on an interface agreement and your responsibility matrix, where all the contractors are involved, and so that you can suss out all the interface issues. Because that's normally one of the places where you find some of the biggest problems during the implementation phase, that you haven't thought about some of these interfaces between the different contractors and the turbine supplier as well. Owner's requirements, just a couple of high level points. You need to cover everything that the contractor should include in his price, especially if you've got special requirements, but do not over specify. In other words, tie down the contractor so there's no room to move. Specify what is necessary and not the Mercedes-Benz that you would want, because we all want a Mercedes-Benz or a Bentley perhaps, but maybe the wind farm can work equally well with a VW. And then the other point is also do not under-specify, because then your contractor might run away with you and you might be getting a lot less than your VW that is really necessary. Also allow adequate time for pricing by the contractor. Here comes one of the more controversial statements. Do not push your contractor too hard on price. I think everybody knows, but I think sometimes people forget. Contractors are not in the business of charity. They need to make money. They've got shareholders. For example, Raubex is a listed company on the Johannesburg Stock Exchange. We have to make profit. So if you push us too hard, I'm talking about contractors in general, there is only one place where you eventually will lose out, and that is the project will lose out, because the contractor will still have to do whatever he has to do to make money. So we need to find a happy medium between allowing the contractor to make some profit, but not overcharge the IPP or the developer. There are always some environmental issues at the planning phase, search and rescue specifically, because sometimes search and rescue is done by the client, and then we get to site, and we've experienced this. We get to site, we start working, and we're 6 months into the project, and now the financiers, for example, sent their own environmental expert in, and all of a sudden they find more plants that are on endangered lists and so on. And all of a sudden work is stopped for another 2 months again, just to now find a way around that. So it's quite important from a implementation phase that you do this kind of planning properly right up front. And then the design review process, often, yes, in terms of the contract, there are clauses, but often that takes too long, and that actually just extends, especially if you have lots of comments backward and forward, that just extends the planning phase, but it then also reduces the construction time. When I get to the EPC contractor and then more the guts of the process that we have to follow, you start with your project schedule, and you need to tie that down, especially along the interfaces with the different contractors on site and the TSA and with the client. One thing which is important, please make sure that you make your contractor responsible for design and engineering. This is key, that you do it a proper EPC contract. There must be a design and a design freeze within necessary approvals, because you can also not be in a continuous design phase. Site visits and geotech studies during the planning phase are also, like I mentioned previously, very important, that detailed geotech studies are done, and that when I talk about this, I'll show you a picture a little bit later as well. But if we move to the next one, the designer must also, especially the designer that does part of the civil and structural design, must visit the site during the geotech phase. And you'll see when I get to that photo as well why I say that. There needs to be an integration between the ESCOM and the IPP substation designs, and it's preferable that the same designer then does that. One of the problems that we often see is the duration of the entire ESCOM design process. And that often also cause unnecessary delays, and you need to work hand in hand with ESCOM, I almost want to say on a daily basis, to make sure that you reduce that time. Then you need to do your planning of your long lead items as soon as your high-level design is done. And then one thing which is always forgotten and becomes important closer to the end is your ESCOM telecommunications design. You also, during the planning phase, you have to do your ESCOM outage planning with ESCOM. It doesn't help you much to only start doing that during construction. And the next phase that you need to plan is your site establishment, accommodation. Where are all your people going to stay, as well as transport for those people to and from site on a daily basis, as well as home for pay weekends or yeah. Then water availability is critical. That normally is looked at to an extent by the developer, but it becomes a little bit more of a planning issue by the EPC contractor during the planning phase. And then also things like, where do we obtain suitable construction material, for example, G5 or bedding sand with a suitable thermal properties for your cable network, so that you don't land in a situation where your cables can overheat. Next one is resource requirements, your own site management people and your own staff that you use on a project. You need to allocate the right people. And then it gets to local labor as well, where you have to start interacting at the planning stage with the local communities in the local towns to find out what are their requirements. Because in some towns, you find there are some elements that are quite, or want to be quite controlling, and you have to follow a very strict process. And other towns are a little bit more laid back, and it's a little bit easier to deal with a local labor. But you need to do proper planning up front. Then you get to your subcontractor selection, because you have to decide up front as well who you're going to use for what part, if you use subcontractors, and also what your plant requirements are going to be for both the civil works and the electrical works. It's critically important that you have good landowner engagement right up front at the planning phase as well. We all know that an unhappy farmer is not pleasant to work with. So if you can find out from the landowners right from the start, what their requirements are, then you can start off on a good foot with a good relationship with them. Also, economic development and enterprise development, both procurement and labor, is also something that gets planned right up front before you start with the implementation phase. And then another item which normally gets left behind is also the technical interface between the turbine supplier and then the balance of plant contractor. Not so much on the civil side, even though, for example, bulk cage deliveries are quite critical, but it becomes very important on the electrical and especially on the Scada interface side as well, that you start looking at that right from the beginning. Next slide, please, Kim. And then we get to the implementation phase, fewer points on the developer side, but this is another controversial one. Please, developers or main EPCs or wind farm projects, please ensure that you appoint experienced owners engineers with construction experience for your site supervision. It has happened, Ntombi said in the beginning, I've been involved in quite a few wind farm projects, and every time you get to a wind farm where there is somebody who is performing the owner's engineer role, site supervision, and that person has 2 years or 3 years experience, never built a substation or an overhead line in his life, then it becomes a situation where you spend 60% of your time on educating this person instead of building the project. So please make sure that you use experienced people, because it benefits the project. It doesn't benefit the contractor, it benefits the project to use suitably experienced people to actually be your site supervision on site. The next one is, please do not manage the project with contracts or non-conformance reports. There must be a personal and human touch when we execute these projects. Too many times you have a situation where people come to site with a big ego, and it becomes a permanent fight to actually build that project. And you can actually reduce the time to build the project same quality to the same standards, because you're doing it to the same specification and design in a lot shorter time. If people have the right attitude and they are coming to site to work together and to really mean that, work together, not say in front of me, we work together, but then you go back to your office and 10 minutes later, the email comes into your inbox and it's completely the opposite to what's just been discussed. Then also another one is, please don't inspect or do any inspections while works are still in progress, because you will find problems. Follow the quality process and make sure that the works executed already are signed off as per the agreed check sheets. And then once the work is finished, then inspect it. Because again, it becomes a paper fight. You know, you've inspected and you come up with a list of 30 items of things that are wrong, and all the responses are, but the work is not done. We will have it when it is done, everything will be correct and perfect for you to inspect. Then another one which we often found is that the main EPC contractor or the developer or the wind project representatives give instructions to contractor site people. Please don't do that. The only time that such an instruction can be done legally is when there is a health and safety situation and the imminent risk to somebody's life or to somebody's safety. Then by all means, as per the OSHA Act, go ahead and instruct that person to stop that activity. But no other interaction with the workers or site staff from the contractor. Please work through the site manager. We get to the EPC contractor. So the first thing that you have to do at the implementation phase is naturally site establishment to get your site camp up and running, to get your people to site, to get all the plant to site. The next one is, and often these things happen in parallel, because in the meantime, your design has been completed. So then you start with your vendor and equipment selection as well. And another important one post-design is the fact that you need to ensure as an EPC contractor that you properly manage with your client the designs, data sheets, drawings, all the documents that you need to submit, the comments that come back for review, responses to the comments. There need to be a very, very clear and documented process for you to do that, so that it's traceable in future. Then another one which is also important in terms of steps is interfaces, and when the construction commences, specifically on the civil side, the access route needs to be built. You know, as part of the design, it's been decided and part of the EIA, but then it needs to be constructed. And also traffic management, especially when there are different contractors, different EBOP and CBOP contractors, that you make sure that people don't get in each other's way. If you want to do a road crossing, for example, with a cable trench, do proper organizing and planning of that. Then also as a contractor, make sure that you actually sign contracts between you as a contractor and all your suppliers and subcontractors as well. One item which is often forgotten, and especially these days with shall I say, wind farm projects going further and further from civilization, is internet connectivity. And you also need to actually almost from the start, besides your construction phase internet connectivity, you need to from the start with the implementation of your operational phase internet connectivity as well, especially if the service providers have to build repeater towers, for example, or install a long haul fiber or something. Factory inspections during equipment manufacturing is key as well. It does not mean a nice overseas visit, but for example, if you're building a transformer or you're having a transformer built in a local factory, go for determine at which phases in the life of the manufacturing you want to go to site. and make sure that you go and do those factory inspections to ascertain for yourself that everything is as per design and as per quality. Long lead time items, the ordering of that, as well as the delivery also starts to happen right from the start of the project, as soon as the design is done and the data sheets and equipment have been accepted by the client. Then also there's sometimes...
Isaac, can I ask you to wrap up in the next 5 minutes?
I will try, Ntombi. I'll be quick with this, and I show my couple of slides, pictures. I'm just going to read these quickly. Then sometimes there's a disconnect between Eskom and the Eskom approved suppliers for the Eskom approved equipment, and what Eskom believes you should receive and what the supplier provides is sometimes, on paper at least, different. Make sure your quality checking process and documentation and handovers on site during implementation is 100% accurate. I don't have to speak about Eskom. You need to make sure that your Eskom interface and Eskom deliverables are executed properly, and you need to manage Eskom's expectation. Sometimes issues come up on site during construction, and this is another one of those controversial items, and it's a storm in a teacup. A little bit of dust around a valve on a transformer, and all of a sudden it's an oil leak. It's not an oil leak, it is just sweating, and there isn't a single drop of oil. And it can be sorted out with a wipe of a cloth, not with a non-conformance report. So storm in a teacup often causes more paperwork and fights than what is necessary. Then also honor verbal site instructions and agreements. Yeah, sometimes specifications are overwritten on site as well. I want to speak quickly about the environmental representative that sometimes, from the client, that sometimes take things too far. When you build an overhead line, part of the authorization is that you have to build at least a jeep track along the line route. We have to get the poles there. We can't fly them in. So that often is a massive problem for us as well. And naturally, grid code compliance to allow sufficient time for that is critical as well. Next slide, please. Yes, so what happens when some of these things go wrong? Just a couple of photos. Next slide, please. This is a typical example. The geotech was done. It showed that there was no problem, soil conditions perfect, but when the excavation started, all of a sudden there's a massive rock and some blasting had to be done. And all of a sudden there's more than a 6-week delay on the project because of all sorts of approvals that had to be done. Next slide, please. This is where the geotech becomes a process, and where there's a serious disconnect between the geotech and the design. As you can see, these soil conditions, I'm an electrical guy, I'm not a geotech expert, but I can see with quite easily on the photo, this is shale, and you cannot install a piled foundation in this case, simply because of the shale, it just caves in. Some of these holes, it's supposed to be a 300 millimeter diameter hole, but it starts off at 500 at the top, and further down it becomes much wider even. So this is a good example of where the design should have been changed after the geotech investigation. Next slide, please. This is the one I mentioned earlier as well, about the width of the environmentally authorized area for the road. As you can see in this picture, there's a 2-meter cut on the left with a 2-meter V-drain and a road and fill on the right. There is no place in this 15-meter environmentally authorized area to put the cable or to plant the overhead line. So this has to be much wider, because you can't put it under the V-drain, or you can, but it's very costly. It's not a clever thing to do, and it's very time consuming as well. You cannot put it in the fill either. So if this was a 20-meter or 25-meter area, it would have been much easier to actually install this cable. Next one, please. This is another one, spaghetti junction, where there is a disconnect between the planning of the design and then the actual execution on site. As you can see, there's nothing wrong with this besides the fact that it looks like a spaghetti junction, but electrically it's still fine, but it just is not a neat solution. Next one. Here, for example, also where you need to make sure that you've got the right contractor. The top one, there's no excavation, just the topsoil is scratched away a little bit, and the cable is lying on top, and the contractor was planning to just put a little bit of sand on top, and on the left there's a proper trench, but as you can see, lots of small, almost to the tennis ball size stones, so that cable will be damaged. On the right hand side is an example of a proper cable trench. Next one. Quickly on risks. The pressure on price, in my opinion, is becoming too high. And what happens then is the standards go down, because if then you start to optimize into stupidity. You know, sometimes you do things for the sake of getting the price down. And we need to, you know, yes, the bid price is the important one, but at some point we need to realize that we still need some standards to comply with, and we have to let go on the pressure on the price a little bit. Also, I believe there's a lack of adequate contractors, especially now with the risk mitigation round and round 5 potentially also having to connect by the end of next year, I believe. So I think that we may be in for a rough ride at this stage. Then also the short time frame of these projects is also, I believe, a bit of a risk, and we need to make sure that we manage this risk very, very well. Last slide, please. Okay, opportunities. I think the development of local labor and the pools of skilled and semi-skilled people is very good, but I don't believe that it should be site-based. I think we should be creating a core of skilled and semi-skilled workers that could be used by the different contractors, because one of the problems that we sit with is we as contractors move from town to town, and we appoint people, and we develop them, and we turn them into semi-skilled workers, but when the project is finished and you move away, they are left stranded right there, still living in the same town, and these newly acquired skills go to waste. Then also another opportunity is that of split contracts, not to have a main EPC, but to have a BOP and then a TSA contract. Then also we recommend that actually we start to engage with Eskom, that the EBOP contractor actually commission the Eskom self-built works as well, with Eskom only witnessing the works and not having to actually do the actual commissioning as well. We believe a lot of time can be saved that way, and it can also help Eskom with capacity. And then also I see there's a lot of opportunity, especially these days with multiple developers working on project clusters, to actually optimize the grid connection design and to optimize the Eskom network expansion that needs to happen for these clusters as well. That's it from me. Thank you very much.
Thank you very much, Isaac. I think that this was a very insightful presentation, and of course, very educational for most of us who are not involved in construction. And thank you so much for taking time to share your insights. And especially the last slide where you talk about opportunities. I think a lot of South Africans are looking into the REEF program and thinking, where can we get opportunities? And we need to share that kind of information. So before we move on to the next slide, I just want to mention that this session for today is sponsored by Norton Rose Fulbright, and we thank you so much for supporting this work that the industry associations are doing. And Matt is going to present after this to give the insight from their side. But, and then the next thing is when you have questions to the speakers, we're not going to address the questions as and when we go. We're going to have a Q&A session. I would like to encourage you to please post your questions in the Q&A section. We will curate the questions and then we'll post them to the speakers at the end of all the presentations. So we move right along to our next speaker. Our next speaker is Dylan Tudor Jones. He is a country manager for Grand Solar Group, and he is responsible for representation and support for all group company activities in the SADC region. Dylan's career in the solar PV industry spans over 26 years, and his experience and accumulated knowledge is in the commercial, industrial, as well as utility scale solar PV industry value chains, which includes project development, EPC, O&M services, as well as commissioning, quality control services, to mention just a few. So Dylan is going to take us through EPC planning and implementation for solar PV projects. And as you can see, he's got a lot of experience. We really look forward to tapping into the knowledge that he's built over this 26 years. Over to you, Dylan.
Thanks, Ntombi. Yeah, there's going to be a bit of an overlap because naturally construction projects have got similar fields of expertise and work packages. So Isaac's presentation was quite comprehensive, and I'll try not to labor any points that he may have already mentioned. Kim, can we move on, please? So just a little bit about Grand Solar Group. It is a vertically integrated group of companies that spans throughout the value chain of both the solar, photovoltaic, and battery storage businesses. The company has been around for 15 years, and in essence, we design, manufacture, and deliver proprietary solar and storage solutions. And because of us being a smaller EPC compared to some of the other Spanish EPCs, I believe that we've been able to grow quite substantially in the past few years, and that's because of our ability to adjust and adapt according to market demands as and when they happen. Kim? Next slide. The main pillars of the Grand Solar Group, just to give a quick overview about the value chain, is GRS, which is the Development and Construction Division. And this is where the EPC contracting takes place, as well as the operation and maintenance on the power plants. ISE is an independent engineering house. It focuses on design engineering of both the interconnection as well as the PV plants, quality control, and testing and commissioning of power plants. PV Hardware is our hardware business. It also has a software division, basically a manufacturer of tracking technologies and fixed tilt structures, and as well as the controllers in the Scada system. And then E22 is the baby in the group. It's an energy storage solution business, both offering the integration of lithium ion as well as flow battery technologies. And in that business, we also have our own power electronics and EMS systems. Okay. So I thought I'd give you start this off with a bit of an overview in terms of the percentage values that go into a construction project. And this is a moving target, specifically in that the PV module pricing comes down, or has come down quite significantly, and continues to do so. So the main equipment on a power plant, on a PV plant, are your modules, your inverters, your structures, and the interconnection work. And the BOP, or balance of system, is really all the activities which connect those together and the work on the ground. So PV module pricing has come down. Today, it accounts for about 35% of the project value. Inverters, and just by the way, that's specific to the technology and obviously specific to the site. Inverters, very similar. If you choose a string inverter over a central inverter, you may end up paying between 6 and 10% of your project price going towards your inverters. Local, this is on the assumption of a 35% local content. As we know, the REEF program insists on higher local contents than 35%. The targets are getting higher and higher. And that may well drive pricing up slightly because of the economies of scale coming from assembly partners in South Africa as opposed to production lines overseas. The structures account for up to 15%. Again, this depends on the topography, which then defines which structures will be used. And the interconnection package itself is defined by distances away from the actual interconnection point, from the land, and cable routing, etc. So you can see that just by doing the right amount of homework and choosing the right main equipment, you have a major influence on your price, because the three major components that go into the solar farm add up to almost 50% of the actual project value. And that's the easy part. That's the part that takes place behind a desk at an office, on the phone, or at meetings with product suppliers. The balance of system is all on the groundwork, and that's where we need to pay a lot of attention, and that's where there is a lot of opportunity to optimize, but also a lot of opportunity to fail if you don't do the correct planning. Kim, next slide, please. So as Isaac mentioned earlier, generally tenders for EPCs get launched whereby the IPP puts out a document pack, and in that document pack, there are KZM files or KMZ files from Google Earth. There are drawings and there's technical specifications. The desktop study then begins by plotting the perimeter of the solar farm on that Google Earth image. Kim, next slide. And once the farm has been, one back, Kim, you jumped one. Once it has been laid out, then the excavation, or at least the evacuation cabling, needs to be planned. Now, in doing so, one needs to be aware of any either overhead or underground cable routes on the way to that interconnection point, be it a substation or just a straightforward loop in, loop out. Any sewage lines, water lines, telecom cables, etc., all need to be considered. Now, this is what the team does, let's say, at the office, whilst they then deploy people to go visit the site, which is the next slide. Now, I've started with really the key information which is required when gathering, when doing a site visit. As Isaac also mentioned, it's imperative to involve the landowner as well as any other stakeholders involved, and those would probably include your IPP themselves, as well as possibly a connection to the local municipality where you will find out good information about the site and the surrounds. The point of interconnection is important to go and visit. The access to site needs to be considered. This includes the actual main road, the distance from a main road to the site itself, any information about the road in terms of its road quality, the width of the road, and if there needs to be any repairs that need to take place on that road. If there's any overhead lines which might affect the safe delivery or block the delivery of large trucks with equipment on the back, those need to be noted, because planning needs to be made in advance to ensure that those obstructions are removed prior to the delivery of the trucks. The other thing is obviously the actual site visit, where you walk around the site and verifying the land conditions, because the information which comes in the document pack might not always be true to what's on site. And Isaac showed some interesting photographs. I've been to sites where there are large sinkholes which need to be filled in and have to be accounted for, where they weren't clearly defined on the geotechnical studies. Also possibly rock outcrops that need to be considered, or shadowing. So that's the type of work that, or things that need to be identified on site. The environmental issues need to be considered. This might involve bird life, it might involve foliage that needs to be removed safely and repositioned, and all has to be planned for. And then in terms of the site surrounds, this really involves looking at the closest town and doing planning relating to the electrical connections, as Isaac said, very important, your cell phone communication and services to the plant. Now, all of that information gets gathered, it then gets collated, sent back to the bidding team, where they introduce any information which might affect the costing, and then ultimately a detailed bill of quantities is put together and sent out to the various subcontractors who work on the various work packages. Next slide, please, Kim. So those work packages I've tried to summarize as opportunities in the next two slides regarding the implementation of a project. And I'll start with the pre-work. As Isak mentioned in detail, there's a lot of pre-planning that goes into these projects, and that happens parallel to, for instance, the procurement and of the main equipment, or long lead time items. So you are going to have involved in pre-work, you're going to have engineering companies that either specialize in interconnection or that specialize in PV plant designs, or both. Parallel to them doing their work at the office, you're going to have your permitting studies, your on-the-ground hydrological studies, geotechnical surveys, and topographical surveys being concluded. And then your land surveyors are extremely important. Not just in what Isak mentioned, but we've had circumstances where a farm owner hasn't necessarily seen eye to eye with the neighboring farm owner, and the fence line has been pegged out 1 meter outside of the official boundary line and pretty much had to be moved. So it's imperative in terms of planning that when you have your land surveyor on site, you have both neighboring farmers on site and visibly checking the layout, signing it off, so there's no future arguments. On top of this, your environmental planning needs to start taking place, your health and safety planning needs to start taking place, and also the pile driving tests, as well as the pull-out tests. Now, this is obviously defined by the geotechnical conditions and will ultimately influence the tracker foundations that are going to be required on site. So all of this needs to start taking place, or that planning starts taking place whilst the major equipment has been chosen. Now, that is a basic procurement process involving modules, inverters, and tracking structures. Then, very importantly, and it could be a derailer, if you don't approach your HR properly, you are going to have problems on site. So the human resources element includes your community engagements, your recruitment of staff, doing that in a very transparent manner, engaging with all the relevant stakeholders in the community so that nobody gets left out potentially, and obviously medical testing, onboarding of staff, skills development of those staff, as well as industrial relations potentially if you have problems. So all of that needs to be planned for well in advance, upfront, before implementation. And then the economic development piece is ultimately the localization of workforces, your local content itself, skills development in the value chain, as well as potential supplier development that's involved. Whilst doing that, well, I'll talk about the mobilization phase, because the local communities is where we get involved in trying to support in terms of localization. This would mean possibly the sourcing suppliers that can assist with the site establishment of site offices, site facilities like construction power, ablution facilities, the laydown areas, getting the site ready, basically the prep road going in prior to the actual main contractor moving in and starting his work. This also includes your leasing of vehicles for the staff, the arrangement of staff transport to and from site, the security fencing around the actual site office itself, as well as security company onboarding. Those security companies need to be responsible for 24-hour security, as well as nowadays COVID testing, or at least temperature testing every day when people come to site, as well as the normal drug and alcohol testing when people arrive at site before they move in. And naturally, we need to make sure that we have access to medical facilities. So it involves the sourcing of local clinics or hospitals, or first aid and paramedic facilities nearby, or ambulance services. If we start talking about the major opportunities on an EPC project, that is naturally the civil package as well as the electrical package and substation package. The civil package I've put together with foundations because it's really the similar kind of expertise that are required. That really, in spelling it out, is your plant access road that needs to be established, clearing of the land, any excavation work that needs to take place, fencing of the plant, and that could include electric fencing most of the time, trenching and backfilling. Isak showed a few photographs there of trenching. That's a very close interface between your civil contractor and your electrical contractor. as well as the water storage, as well as water supply. Very important to try and secure that up front. It is a IPP responsibility in terms of identifying it, but ultimately that gets pushed down onto the EPC as well as the O&M contractor for long-term water availability. And ultimately the guardhouse is included in the package, as well as the actual operation and maintenance building, which includes the storage facility. Foundations are a big piece of the contracting. It might be sub to a specialist, but these foundations include the foundations for those structures I've just mentioned, as well as for the trackers themselves. That depends on the tracking system, and depending on the geotech, you may or may not need foundations. You may just use straightforward ramming of posts into the ground. The trackers require, or at least the motors for trackers require a large foundation if you are using a tracker which has got a single arm architecture. These are trackers where you have a single arm pushing multiple rows or racks simultaneously, as opposed to having a motor per rack. The foundations are different. Then naturally the inverters need foundations, the combiner boxes, weather stations, the CCTV cameras, etc. All needs foundations, and that falls into the civil works package. The electrical contractor is typical electrical work which takes place within the field, and that's including the supply of components, cabling. Very important, I'm going to stress this, is lightning protection and earthing. A lot of the early stage round 1 and 2 solar projects have had consequential issues when lightning is involved, and it's taken out inverters, it's taken out communications, and they've had to do remedial work to try and fix it. So very important to do that planning up front, because it has, it could be an oversight. And then naturally the communication cables also falls within that work package. The switchgear, substation, and interconnection typically goes to a single contractor who specializes in your switching stations. So that would be involved the supply of the transformers, switchgears, sometimes capacitor banks if applicable, and then obviously the transmission lines that feed into the interconnection point. Kim, next slide, please. Then we move on to mechanical works. Now, mechanical works is really the installation of the tracker. So it's a company that specializes in either drilling or ramming of posts, and then the assembly of the Meccano set that makes up a tracker. It's important to ensure that that same company does the actual mounting of the modules on the tracker. And that is to ensure that you don't get a finger pointing game where one says, well, they're not aligned because the other party did it, and you end up having to try and deal with a fight on site. Logistics, very important. Most of the time, the major equipment suppliers arrange their own logistics to site, but it's a big piece of the puzzle, and it's also imperative in terms of planning, route planning, and also using the right trucks to offload equipment and to deliver equipment without damaging it en route. I've seen some horrendous photographs of sites whereby the containers were not offloaded by a professional and equipment was damaged and during that offloading process, and then your whole project gets delayed, specifically if it's a long lead time item that's been transported. The Scada system is done by a specialist typically. They design, install, and commission their Scada system. Security system, similar approach. That usually involves the perimeter fencing and the CCTV cameras. And then quality control is often carried out by the same engineering company that does the design, but can be a third party too. And usually it is that engineering company that gets involved in the startup and commissioning of the plant, as well as the professional engineers that are involved in the Scada system, as well as the security system, all on site right at the end once the system gets started. And the tracker system. And then I want to just mention a few commercial cost considerations that cannot be ignored. And EPCs need to make allowances for the legal fees that are involved in closing these contracts, insurances, and all the bank charges in terms of guarantees and warranty bonds that need to be put in place during construction that roll over into the O&M phase. So that's in a nutshell. I hope I've caught up. really a high-level view of the implementation and the opportunities in EPC. And I'd like to close with a thought for everybody to consider. Different IPPs have got different ownership structures, or at least ownership aspirations. And those who have a long-term view on their projects will choose quality over price. But this wise old man, Mr. John Ruskin, had a saying, which I always like to quote because it rings true to our industry and any real procurement decision. He said, it's unwise to pay too much, but it's worse to pay too little. When you pay too much, you lose a little money, that's all. When you pay too little, you sometimes lose everything because the thing you bought was incapable of doing the thing it was bought to do. The common law in business practice or in business balance prohibits paying a little and getting a lot. It can't be done. If you deal with the lowest bidder, it is well to add something for the risk you run. And if you do that, well, you have enough money to pay for something better. And if in Afrikaans, they say, goedkoop is duurkoop. And it's a good way to just sum up what John Ruskin was saying many years ago. Thank you, Ntombi. I hope, as I said, I've caught up for everybody.
Oh, thank you so much, Dylan. That was really interesting. I mean, the quotes in the end, cheap is expensive. And we see it across the board. Even in personal buying decisions, you buy cheap, you're gonna buy 4 times more because it's gonna break in a couple of days. So thank you for that. And thanks for a very insightful presentation. I think your focus on solar PV has really given us an insight of the difference between the construction of wind projects and the construction of solar PV projects. So we really appreciate you taking time to educate and share your knowledge with our audience.
My pleasure. Thank you for having me.
Thank you. Our next speaker is Matt Ash, and he's a director at Norton Rose Fulbright. Norton Rose is our sponsor for today's session. Like I've said before, Matt is a projects lawyer and he focuses his practice on energy and major infrastructure projects. His key focus is on construction, operation, and supply agreements across the full spectrum of energy technologies, which includes solar PV and wind. His recent construction experience has included appointments in more than 30 projects across the REEP and risk mitigation procurement programs. Today, Matt will take us through challenges and hurdles experienced by renewable energy projects in construction, and we look forward to hearing from you, Matt. Over to you.
Thank you, Ntombi. Good afternoon, everybody. Just as a little word of introduction, yes, I'm part of Norton Rose Fulbright South Africa, which is a member firm of a global law firm across the world, which has a preeminent global practice in the energy sector across all technologies and functions, running from finance to construction operation, fuel and other resources supplies, land issues, environmental and other permitting, corporate and commercial, the full gamut of what one might expect from a particular energy project. Just a bit of a shameless plug. I'm delighted to see that UVI is one of the key sponsors of this particular developing developers program. Just a little bit of a health warning. I was privileged to assist UVI in round 4 of the REEP program in the construction and operation agreements for 3 projects, which they actually executed and delivered all together on time and within budget. And I like to think it's because it was such an excellent set of EPC contracts that we managed to do so. But of course, it all lies in the interface between the employer and the contractor to develop and deliver a project together. Okay, so just to briefly highlight what I'm going to cover today, there's going to be a lot of overlap with what Isak and Dylan have had to say, because of course, many of the issues that they have highlighted are some of the challenges and hurdles that an employer and an EPC contractor will have to surmount in the execution of a construction project. for these particular energy projects. So my program is just to highlight a couple of the more prevalent issues that we come across in the execution phase. Delay, performance issues, and that performance pertains to the equipment. Defects, which would include serial defects where applicable. Force majeure, just a brief word on that, particularly in the context of COVID-19. There's some corporate and commercial questions which I'd like to highlight because they do present certain challenges. One of my big bugbears as an I should rather say a reformed disputes lawyer. Half of my career was in the disputes sector on energy and infrastructure, and so disputes mechanism is a key concern of mine. And then some concluding remarks. Next slide, please, Kim. So we're going to gallop through a couple of these issues, and the first one is delay. Next slide, please, Kim. Next slide, please, Kim. Thanks. Okay, so the key catchphrase is on time and within budget. That's what both the employer and the contractor want to achieve. Under the procurements that we're dealing with here in South Africa, REEP and the risk mitigation program, you do have time being of the essence because the fact that the time for completion of the project is determined by the scheduled COD that's stipulated in the PPA. So the construction program is informed and directed by that scheduled COD, which means that there's already a fixed target for the delivery of the facility. So there are three sources, essentially sources of delay from the employer side, the contractor side, and then force majeure. Next slide, please, Kim. So from an employer delays perspective, issues could include the delay in issuing the notice to proceed or affording the contractor full and undisturbed access to the project site, or a delay in approval of designs, plans, or processes where such approval or sign-off is required. Or, for example, delay in issuing required variations to the particular contract matrix. What I'm going to do on each of these is to not just point out the problems, but also point out and suggest mitigations and incentives. By incentives, I mean encouragement to the contractor in particular to be able to mitigate or surmount these particular issues. From a mitigation and incentive perspective in employer delays, that the contractor is going to be entitled to an EOT. An EOT is an extension of time. So the incentive to the employer is to ensure that it does not delay the progress of the works through, for the examples that I've given earlier, because what the employer loses is time in days at the back end of the PPA if it doesn't meet its scheduled COD. That COD is commercial operation date. So there is this incentive on the employer to make sure that it has its house in order so as to not to delay the project. Next slide, please. Okay, from a contractor delay perspective, there can be delay in commencement. Now, you might wonder, what could that possibly be in the contractor's interest? Well, there are many examples where the contractor may precipitate or cause a particular delay in commencement. For example, when I give these examples, it's going to be on a no names, no pactoral basis, because one doesn't want to criticize particular projects. But one example is where an order for particular parts of the equipment was placed by the contractor to its subcontractor 3 months late and had an immediate knock-on effect to the construction program. Now, yes, when we deal with the development of a construction program, typically one finds that, of course, taking into account the fact that time for completion is going to be the scheduled commercial operation date, The construction program is developed in such a way that there is a float built in. Who owns the float depends on how the contract is crafted, but where there is a very tight deadline for execution of projects. I'm thinking in particular now coming forward of the risk mitigation program, where some of these very complex projects are going to have to be delivered to commercial operation in a very short space of time. There's going to be very little float, as a consequence of which a delay in commencement can have a massive effect on the construction outcome. Another one is site issues. You know, both Isak and Dylan have emphasized the fact that that early visits to the project site are not just recommended; they're in fact imperative, because there are these lurking aspects which could affect the outworking of the project. Just for an example, on a particular small hydro project, if one did a desktop study, but without all of the information to hand, one wouldn't have appreciated that one of the water channel flumes to channel the water from the main offtake point through the power station and then back into the into the river would not have picked up that channel crossed an Eskom servitude and just wouldn't have been permitted to be built. On another one, on a building of a wind farm, looking at the access to the particular project site, only the site visit revealed that, but hang on, there are 3 bridges. We can't really call them bridges, but they're really dirt roads crossing, you know, those concrete pipes, had to be widened and strengthened to be able to take the trucks delivering the tires and blades. That wouldn't have been picked up had there not been a site visit. So it's these things that are absolutely critical. There's also this question of contractor delay through just slippage in the construction program. How do we deal with this to mitigate and incentivize? So first of all, there needs to be a proper site visit and proper early works, which I will deal with in a second when we deal with site risk. The constant monitoring by the employer's representative, and I need to echo what Isak said earlier, and I'll come back to it really as a final comment about how important the role of the employer's representative is, even in a fixed price turnkey EPC contract, full wrap contract, where you would expect the employer's representative to kind of be hands off because it's all over to the contractor. The employer's representative role is really crucial, and if you're going to have a representative, you might as well use it. Most importantly, to mitigate the effect of contractor delay is this concept of delay liquidated damages, which exists where the contractor fails to meet time for completion. I'll deal with it in a little more detail further on, but essentially what it is that it's a pre-estimate, a genuine pre-estimate of the losses which the employer is likely to suffer as a consequence of the contractor failing to meet TFC. Next slide, please, Kim. So how do we deal with these properly? Upfront mitigation. It's all about the base contract. So in the contract, it's imperative that, notwithstanding the standard FIDIC type provision that the contractor will within 30 days provide a construction program, that's just simply not good enough in these kinds of procurements. You're going to have to want to, and I'm talking from a developer's perspective here, you're going to have to want to agree with the contractor upfront what the detailed construction program is going to be, and that construction program must highlight what elements of the program are critical paths, because that is going to determine whether or not the contractor is going to deliver the facility on time and within budget. There need to be express provisions dealing with site risk and concurrent delay. I'll get to concurrent delay and site risk in a second. there need to be monitoring protocols for the employer's representative. Look, those don't necessarily need to be set out in the EPC contract, but certainly in the contract between the developer and this employer's representative that may be appointed. Because, as I say, it's pointless having a representative that you're paying for that is really of little value, unless that representative is really there front and center looking after the interests of the employer. You need to ensure that the delay liquidated damages package is adequate to cover the anticipated risk. And this you can only craft having regard to all of the project exigencies that you anticipate that may arise during the program. I've put in a final bullet point there, which is a bit of a Walker's killer, to stimulate maybe some discussion and debate. But there are certain projects where there's certain milestones on the critical path that are just absolutely essential to be met. And how does one incentivize the contractor to meet those? Because the contractor says, well, look, in the ordinary course, I only am on the hook for DLDs if I don't meet my time for completion. And don't worry, I'm going to make sure that even though I'm in delay here and now, I'll make it up in the contract program. And that's a risk. That's a risk to the project. And I can't tell you how many projects we've come across where that kind of situation has arisen, and notwithstanding the best endeavors and efforts of the contractor, it's just not able to make up the lost time. And as a consequence, the lost time just grows and grows and grows to beyond what is capable of being covered off by a DLD package. If you've got a DLD package, for example, that is going to run and covers maybe a 6-month extension of the contract program beyond time for completion. But in actual fact, because of the actual delays, there are inadequate DLDs to cover it, because the actual completion is going to be 8 months beyond TFC. You've got a 2-month gap, which, you know, if you're looking at some of these big pumper projects where DLDs run at 5 million Rand odd per week, that's a lot of money for a 2-month non-covered delay. So what can one do to try and incentivize the contractor to concentrate its mind to try and make up the program properly? Well, maybe not interim DLDs, but maybe just off the top of my head, a deduction from milestone payments paid into escrow to say to the contractor, well, you'll get paid that money if you make it up. So the moment you make it up, so you've still got all the draws that go down, but a portion of that draw gets put aside into an escrow account, and you say to the contractor, okay, but if you want this money, it's a prepayment of DLDs, and if you want this money, then you're going to make up the contract program now. So it incentivizes you. That's just a throwaway, or throw it into chuck it into the pond for people to consider, and maybe stimulate some discussion and debate. Next slide, please. Performance. The next slide, please, Kim. So these performance issues really deal with the performance of the equipment, and the first element is the equipment may not perform properly or as warranted owing to an inadequate or deficient design. So the mitigations and incentives are, and here is an echo of what Isak had to say, the employer's representative and the lender's technical advisor that is appointed, and the developer has influence over the appointment of the LTA. Those individuals or organizations must be technically qualified and competent to review designs on an informed basis. It makes no sense where, for example, an owner's engineer has great PV experience but is appointed to do a biomass boiler project. You know, not all animals are equal. You need to appoint a properly qualified ER and LTA that has the experience and the knowledge and has delivered on the particular type of project that you're dealing with. Just from a design perspective, also one of the crucial mitigators for inadequate or deficient design is PI insurance. But the trick there is to make sure that that PI cover is sized correctly. It's pointless having 5 million rand PI cover where the consequences of the deficient design cost the project 500 million rand. Next slide, please. Okay, from an equipment performance point of view, the next element, of course, is manufacture. So there may be defective manufacture of critical components in the equipment. Just to give you an example, on a project I did some time back, there were defective welds on boiler pipes, and that was part of the manufacturing process. Now, fortunately, that was picked up by inspection and testing when the pipes were delivered to the project site. But the point there really is that could that have been mitigated earlier? Again, the employer's representative, the LTA, must be technically qualified and competent to monitor the manufacturing on an informed basis. And then the next bullet point, I hear what Isak says about, jaunts overseas to go and look at things. But if you've got a right under the EPC contract to monitor the manufacturing process, use it. There are so many cases where if there had been a modicum of just observation and verification of manufacturing processes, that enormous pain later could have been avoided. So my earnest recommendation is that developers should provide adequately from a financial or commercial point of view to empower its employer's representative to keep a proper handle on the manufacturing process. Of course, the mitigation for the employer and incentive against the contractor are the performance liquidated damages that would be payable in the event that the facility is not able to perform as specified or in conformance with the warranties, the performance warranties that have been given. And of course, that there are minimum performance guarantees typically in these projects where if those are not achieved, that would entitle the employer to reject the facility and then be repaid everything, the contract price, and then certain break costs that are pre-agreed that the contractor must repay. So, I mean, effectively what happens in those circumstances, and that's an all fall down situation, which hopefully is never reached, it costs the contractor probably around about 110 to 120% of the actual contract price. Next slide, please. The final element of equipment performance is the installation and commissioning of the equipment. There may be problems in actually installing the equipment. I mean, we've seen the fact that towers are erected incorrectly, or foundations for the towers that I'm talking about from a wind perspective have not been adequately founded or constructed. Or, for example, that the fixed tilt racks for solar PV modules are inadequately founded, or that the actual modules themselves, when installed, are negligently racked, which results as an equipment failure during the commissioning and testing. Again, emphasize the employer's representative and the LTA being technically qualified and competent to monitor installation and the performance tests on an informed basis. And if you've got the right to monitor the installation and testing and commissioning, do it. Give the employer's representative that opportunity. The mitigations for the employer and incentives against the contractor are, as again, if there's a delay, then delay liquidated damages. If there's a performance issue, performance liquidated damages. And then, as I've said before, there are the facility rejection provisions in the event that the contractor is, the facility fails to meet the minimum performance guarantees. Next slide, please. Okay, from a defects perspective. Okay, and I just want to deal with the question of defects notification period and then the question of serial defects. So the problem here that we've found in a number of projects is that defects begin to present after expiry of the defects notification period. And as a consequence of that, there's an inability to require the contractor to replace the defective equipment at its cost. So what are the mitigations and incentives? The mitigation from an employer's point of view is to make sure that the DNP is sized correctly. In other words, to how long is the DNP going to be? Is it going to be 12 months? Is it going to be 24 months? Is it going to be 36 months? This all very much depends on the context and the equipment. So for example, typically you may find on a wind farm or a solar PV project that you've got, depending on the size of it, a 24-month defects notification period. On a biomass boiler, you would probably find a 36-month defects notification period because the propensity for defects is that much larger on thermal power station projects. Again, the important element to mitigate any particular loss is the size of the performance or retention bond for the contractor's obligations during the defects notification period. And then finally, and this is a point that is to be emphasized, there need to be enforceable manufacturer's warranties. And I underline the word enforceable because, and forgive me for mentioning the jurisdiction, but it's only because of hard experience. If you've got a manufacturer sitting in China, let me tell you that it is extraordinarily difficult to go and enforce a manufacturer's warranty in China. So you want to make sure that where possible, you've got these manufacturer's warranties that are like klinkende geld, as I say, readily enforceable almost in the same way as a performance or retention bond. Look, a manufacturer's warranty in certain jurisdictions is really only going to be as valuable and dependable as that particular manufacturer's desire to maintain its presence and position in the market. So for example, if you've got forgive me, I'm going to say it like it is, a bum panel produced by a fly-by-night producer, you get what you pay for. I think that last quote from Dylan is absolutely on the money, pardon the pun. But, you're going to get what you pay for. So it very much depends on what is the risk that you're prepared to take just because you want to shave price. Next slide, please. Serial defects. Okay, a serial defect is the same or similar defect in the same equipment or component within the facility, and this obviously impacts on the overall facility performance. So what you want to do from a mitigation perspective is to ensure that the contract provisions have percentage thresholds to establish serial defects. So for example, on a solar PV plant, you may say that if the same defect presents within 5% of the modules, either in the whole facility or within a particular production lot, if that's appropriate, then that's deemed to be a serial defect, which then triggers a whole bunch of contractual provisions as to how you deal with the serial defect. That's a root cause analysis, and an understanding of precisely what the issue is, and then once you've determined what the issue is, the contractor rectification plan. The incentive for the contractor is that if the serial defect delays the project, it must it's going to pay delay liquidated damages. If the serial defect, notwithstanding rectification, continues to affect the performance of the facility, then they're going to be performance liquidated damages. And then again, of course, even with the rectification, if the facility doesn't meet the minimum performance guarantees, then the facility rejection provisions. Again, to emphasize, the enforceable manufacturer warranty is crucial in these circumstances. There have been instances where a manufacturer has been required to replace the entire module deployment of an entire solar farm because of a serial defect. Now,
Matt, can I
yes?
Can I ask you to start wrapping up in the next 5 minutes? Sorry,
Yes, I will.
I know it's rude to disturb the guy who's holding the press.
No, forgive me, I do talk too much. Okay,
Thank
let me
you.
gallop through. So next slide, please. Okay, very briefly on force majeure. I don't want to spend too much time on this, except to emphasize that the only reason why contractors were able to claim force majeure during COVID-19 here in South Africa was because the FM definition included the word embargo. And from a mitigation perspective going forward, that you want to ensure that project documents definition of FM include epidemic, pandemic, and response actions by the relevant authorities, because it's those actions that actually cause the construction to stop, not necessarily the disease. Next slide, please. It's very important from an FM perspective for the employer's representative to pay attention to notification and mitigation provisions. Typically, an EOT is given to the contractor to demobilize and remobilize, and that's included on the actual downtime for construction. But productivity ramp up, you need to consider very specific provisions in the contract to deal with that and whether in fact it is applicable. Note that that's typically the FM provisions do not entitle the contractor to claim costs as a consequence of FM, and you can consider including in your contract a discretion to the employer as to whether to grant such costs. Next slide, please. Just very quickly on this, performance security, as Isak and Dylan have pointed out, security costs. And it's going to be the contractor that has to pay this, and so it must price accordingly. Again, there needs to be appropriate sizing of DLD caps, PLD caps, and aggregate liability. The employer's representative must monitor very carefully the expiry of performance security. And you will see there that on mitigations and incentives, the employer must do its due diligence of the contractor at contracting stage, its financial standing, its track record, because that's going to inform the caps. And we recommend a full risk, pre-contract risk matrix analysis so that all of the risks are covered. Next slide, please. One thing that from a corporate and commercial perspective is this question of the contractor as equity participant. The slide is really self-explanatory, and what we say is that if the contractor is going to have equity participation in the project co, then potential conflicts of interest must be done at shareholder agreement level, and that careful attention must be paid. Next slide, please. Okay, my bugbear. Dispute resolution framework. Very simply, one size fits all boilerplate plug and play clauses lead to much material regret, because by the time the parties are fighting, they can't agree on any dispute resolution mechanics. So typical clauses that say, okay, well, AFSA arbitration or whatever, they're not appropriate for the expeditious and effective resolution of daily technical issues. So we recommend a bespoke dispute resolution schedule. I can hear my colleagues just saying, oh, there goes Matt banging his old drum again. But let me tell you that the money that is spent in crafting this, and the time and money and effort spent upfront crafting this, saves by a factor of 10 the pain that is suffered later in the event of a dispute without such a mechanism that includes fast-track independent expert determination of technical and financial disputes. Next slide, please. It should be the final one. Yep. Okay. Do the hard yards up front. Spend time and effort on EPC contract requirements, the particular conditions, and I do recommend that as far as possible that employers do hold the pen, because then you're going to be able to determine what you need. You need to do a proper due diligence on the proposed contractors, and vice versa. Contractors need to do a proper due diligence on the employer, although the risk to contractors is much less in that these are project finance transactions, and so it's lender money that's being paid, not actual employer money. We strongly recommend that in the process that there for the appointment of a contractor, there are tender processes that maintain competition, not to just drive price, but to drive deliverability. You want to keep the process, if I may put in inverted commas, honest. And then finally, and this is quite an important point, and it speaks to what Isak and Dylan have both said. Your selection of professional advisors, that's the owner's engineer or employer's representative, your financial advisors, your legal advisors, they need to really understand the product technology and the consequent particular risks in the project construction phase. I have an old saying, if you haven't touched it and felt it and smelt it, you can't draft for it. So that's from a lawyer's perspective. And, I insist with my teams that we're involved in these kinds of projects. We go out to the project site at an early stage and we tramp across it to understand what it is and where it is going to be built. And then we go to the manufacturers and we go and have a look at the kit to see, well, okay, how does this stuff work and what are the risks? And then informed by that sort of thing, when we come to draft risk matrices, or we draft EPC contract terms with particular conditions, we're doing so on an informed basis. That's my bundle.
Well, thank you so much, Matt. I really like the fact that you don't just present challenges, but you also included the mitigation measures and incentives, especially the part where you mentioned contractors meeting project milestones during the construction program rather than waiting for time to completion. I'd also be interested to hear from other EPCs what their appropriate incentives would be to make sure that they encourage contractors to meet their milestones during the project. So thank you so much for that. We'll be taking questions in the Q&A and we'll pose after the last presentation. And I'll move on to the next presentation. Thank you, Matt. Can I encourage you, audience, to please post your questions throughout in the Q&A so that we don't get an influx of questions in the end because it gets difficult to manage. Our last speaker for today is Simone Zanot. He's a commissioning leader at NL Green Power. Simone is a nuclear and energy engineer. He joined NL Group in 2010 and he has worked in a number of countries and is currently in charge of coordinating NL Green Power's commissioning of renewable energy projects in South Africa and Australia. So he's going to talk to us today about commissioning of RE projects, which includes connection agreements. Over to you, Simone.
Thank you. Thank you. If we can go to the next slide, please. Let's present today's agenda. So we'll show you the purpose of this presentation and explaining what is commissioning, what is renewable energy commissioning, with a focus on the wind projects. But actually, you will see that the same concepts that I will discuss with you about wind are applicable also to solar technologies. So whenever you will read the WTG, wind turbine generator, you can put a power conversion unit with inverters of the solar technology. And then we will make a focus about a typical sequence to get the commercial operation date tests approved and the interfaces with ESCOM and RETEC. And I would like to share with you the main lessons learned during commissioning, so that everybody can a bit benefit, the whole industry can benefit about our best, let's say, practices. So this introduction was already done, so let's skip it. Not to optimize the time. So today's presentation will focus at explaining what is commissioning and which are the stages from the start of commissioning to the final operation, with a focus on wind projects. And we will share the lessons learned also for your use. So please, next slide. So we discussed a bit what this word commissioning, but what is commissioning? So, in order to explain you what is commissioning, I always use this analogy. So, would you ever buy a car which has never been tested before, and without knowing the safety parameters, its performances? Well, guys, I guess not. So please, the next slide. We can think about the process of a car before we buy it as divided in 3 stages. There is somebody who designs the car, a sketch, no, and then the sketch becomes reality. So somebody builds it. Then then there is somebody who is going to test this car. No, usually we saw on TV, no, the crash tests, no, with the dummies, for example, or in this case, no, the emissions test and the performances. And then finally, the car arrives to the car dealer, and then we buy, and then we finally drive it. So how do we translate it this into renewable energy commissioning? Please, next slide, Kim. The life of a project, renewable energy project, also thermal, whichever project, can be divided into 3 stages. Construction, where somebody designs and builds the plant, the wind farm, the solar farm, installing all the components that are foreseen in the design. Then we have the final stage, which is called the operation, that is when in this case, the wind farm, the blades spin and generate electricity, and then we are remunerated. And then actually there is a link between these 2 stages, which is the commissioning, where somebody is going to test all the equipment in order to make sure that the design, that the installation matches with design, and in this phase, there are some tests are being carried out in order to ensure that the final operation performances are met. Please, next slide. Thanks, Kim. Commissioning can be divided into these stages. Cold commissioning, which is the functional test, the functional checks, which are performed on each single equipment, using also temporary support of a temporary supplier of power, fluids. And these are required after we install the equipment. After all the equipment and the components of the renewable energy plant have been installed, there is a part called hot commissioning, when the plant is finally energized by the final and source of energy with normal supplies. And in this phase, we have to ensure the compliance of all the components, all the systems that we installed into the project in compliance with the project specification. In the hot commissioning is when actually the blades of the turbine spin for the first time and generates electricity for the first time. So first generation, first synchronization. But the plant doesn't pass from 0% to 100% of the generation. There is a part, an interim part called ramp up, where portions of the plant are being commissioned step by step, and checks are being carried out in order to make sure that the performances are always met. And finally, the commercial operation COD, commercial operation date tests, are being carried out, so that once these tests with the transmission system operator and also external stakeholders, for the case of South Africa, for example, with RETEC, we'll see later, are approved, the construction commissioning stage of the project is over, is completed, and the project can be handed over to the operation phase. So the so-called service contract will be activated at the very end, and the operation is basically when we turn the key of our car, and finally, we ride with the car. So similar, the analogy, is now I think well understood. So next slide, please. if we want to translate this into a wind project, or also a solar project, no? In the cold commissioning, all the turbines, all the wind turbines, all the inverters, trackers, PV modules, once they are installed, they are tested and checked. And there is also another part of the plant, very important, which is the substation, no? Which is basically where we step up the voltage, and then where we connect with the existing grid, with the existing transmission network. And also in this phase of cold commissioning, the tests, the functional tests are being carried out, and all the procedures are approved and finalized before starting with the real energization of the substation first, and then the solar field or wind field later, to transition from cold commissioning to hot commissioning, which is the stage when the substation is finally energized for the first time from the external grid. We supply with power the power conversion unit, with the inverters and the trackers in a solar farm, or the wind turbine generators in a wind farm via the HVC equipment, the HV cables, so the so-called collectors, which link the substation to our generating units, either a wind turbine or a power conversion unit. And the hot commissioning is when actually the first, let's say, electrons flow in the direction towards the grid, so towards the external grid. We generate for the first time. And the ramp-up period is when the period when from the first one till the last one, WTG or power conversion unit are hot commissioned. The reliability tests are performed and passed, and very important, the Scada and the PPC, basically a big laptop. I don't know, some of you, many are not familiar with these acronyms. So basically a big laptop collecting information signals from the network and from the wind turbine or the power conversion unit. This big laptop receives all the information, and based on the inputs coming from the grid, it responds and commands to the turbine or the power conversion unit how to behave. So this part, the integration of the turbines or the power conversion unit into the plant Scada, this big computer, and then everything is ready for the commercial tests, for the commercial operation tests with ESCOM and with REDEC. Then sometimes it can happen that minor jobs have to be still carried out. For example, installation of some chairs, desks into one office, or something has to be, something really minor has to be rectified inside a turbine. Some panels have to be replaced. And this is the punch list, the pending works that are being carried out after the ramp up. And then finally, once everything is closed, the handover is the plant is ready for the handover to the operation and maintenance company, which activates the service of the equipment installed at the farm. So next slide. So this is a bit long. I know that we are a bit running late, so I will be very quick. Commissioning is very structured and follows usually a list of activities in sequence which have to be carried out, and everything has to be filled in series so that we cannot skip one process. So we start from studying the drawings, the documentation, till installing and testing at site the equipment, arranging the kickoff meeting involving all the parties involved at site, and also the external parties. By external, I mean who is not, let's say, part of the project itself. So, for example, the transmission system operator or a third party, which will come in, which will play a key role also in the next steps of the project. And then we perform the cold commissioning. Next slide, please. We finally set up the communication first in order to perform the point-to-point and end-to-end communication testing with ESCOM. We finalize the procedure, and then we are finally authorized by the transmission system operator to energize our substation, and then also our bus bar, and the circuit breaker, the gas insulated switch gears. Next slide. And after the substation is energized, we energize the HV collectors, which link the generating systems, the power conversion units, or the wind turbines to the substation. We energize the wind turbines or the power conversion units in case of PV. And then we perform the hot commissioning activities as per procedure, startup procedure, which is prepared by the manufacturer, by the vendors. So also this startup procedure is a big list of activities, a big checklist, which have to be duly, let's say, respected in order to carry out the commissioning activities. And finally, once all the activities are carried out and checks are performed, the reliability run test, so a certain time of hours of continuous production of the wind turbine or the inverter is carried out. And then also in parallel, it has to be done, the hot commissioning of every single equipment that is required in order to perform the commercial operation date tests, namely the power plant controller, the Scada, but also the MacMaster for example, installed in wind turbines. So all the ancillary systems that are required for the next step. Next slide, please. Thank you. The next step being now the sequence of tests to get finally the COD. So obviously this is not, let's say, how it is an exhaustive list of activities that has to be done. Obviously, there are also, in this case, there are specific grid code compliance procedures to be met and steps to be followed. Here we are sharing, for example, some of our experience about even some steps where let's say skipped in order to make a bit more concise the presentation. But basically we can see 4 stages where we perform the dry run test and SCADA functionality test with ESCOM for our pharma. We perform a report and request the approval from RETEC, who comes to site and basically repeats what was done earlier during the dry run test, and checks that the wind farm or solar farm matches with the grid code compliance. And then there is a final step where the independent engineer is appointed, and it will be the interface with the single buyer office in order to get the COD approval. So next slide, please, Kim. So these 4 stages, the dry run test is a performance actually test where we need also the availability of wind resource to perform some tests. The list, as I said, is not exhaustive, and it will be fundamental to provide a report, a detailed report with raw data about these tests that have been carried out, and show the compliance with the grid studies, so that the installed and commission matches with the original grid studies. We have also a part in the first stage with SCADA functionality tests. So basically, ESCOM sends some signals, some inputs, and they have to see that the plants respond as per a certain, let's say, the requirements set by ESCOM within a certain time. And these are some tests that are obviously described in clear detail with the procedure shared by ESCOM with our wind farm. And after we perform these 2 steps, we are ready to involve RETEC. So we share with them the the reports approved and request them to come to site to witness the COD grid code compliance test, and but we have to make sure that the wind resource is there. So in accordance with the wind resource availability. So we ask them to come to site. Next slide, please, Kim. So that in this stage 3, we perform the dry run test, and sorry, the grid code compliance test with retake at site. We perform also an inspection about the wind farm and see that and can assess that the farm is actually built as per design, is performing as per procedures, as per grid code, in compliance with the green code. And we are ready for the next steps, which are the final one, the fourth, the final one, which involves, let's say, some stakeholders that are the interface with the single buyer office, namely the independent engineer who submits the unit completion certificate, so assessing that the capacity has been the requested capacity has been achieved and commissioned, and then we finally get the COD approved at the end of this process. So next slide. We are almost close to the end, guys. So in terms of our main lessons learned that we want to share with you is that let's say the process of commissioning is quite complex, and it's fundamental to define owners and tasks, or owners of certain tasks and deadlines that have to be respected. So the person shall be the same. He has to be to have clear in his mind, her mind, what has to be done in which timeline. And it's fundamental that all the parties involved in a project really understand the procedures, the parameters, even the single parameter about voltage, about active, reactive power, technical parameters, and the requirements of format of the report, or specific requests that can come up during the tests, so that all the parties from the site team, the construction and commissioning team, the engineering in back office, and the specialized testing team are all aligned, and so that the report is finally, let's say, is aligned with all the previous steps. And it's fundamental also to anticipate, optimize, and minimize, once we identified all the activities, the things that can be anticipated. For example, working over the weekends for some reporting activities. There are some activities that have to be done only during working days, like, for example, the Scada functionality tests with regional and national ESCOM, and some activities like prepare the report, which can be done during the weekend at night. This allows minimizing the time required for the report preparation, so that, as we said earlier, all the team knows knows which are the timeline, the tasks, the deadlines. And in case of external issues, internal, some failure of equipment, or external, like there is no wind, have already a backup plan. So in case of internal issues, if we have a failure of one equipment, have already at site the backup parts, the spare parts. In case external issues, wind is not available for today's test, let's see if we can postpone this test at 6 p.m. later. Are you available, guys? Is the site team available? Is also, for example, retake team available to do the test in the late evening? So it is important to act fast and implement any remedy action, let's say, during this process. And last, please, Kim, next slide. Should be the final one. Yeah, in order to get to the commercial operation, there are 3 comms in my mind. So commissioning, so everything shall be ready in the window solar farm and tested as per cold and hot commissioning procedures, and all the systems required to carry out the COD test, the met masts, the Scada, the PPC, have to be live and commissioned. But there is also an important part about the communication, so to share in advance with all the stakeholders the procedures, the deadlines, the target dates, as soon as we have clear the commissioning activities and also wind availability in terms of wind resources, so when we can do the tests, and also not only keep this for ourselves, but share also with especially external stakeholders, because they are the first one to understand our criticalities, and I'm sure they can always help us and share also their proposal in case we need some support from them. And then the complexity, which is the key word, I think, for this year. I don't know how many times you heard this word, me every day at least 10 times. The COD, the commercial operation achievement, is a very complex process in which many parties, stakeholders, shareholders also are involved, both internally and external to the plant. So we have to make sure that we identify all the challenges, and we identify any issue in order, obviously, if possible, to either anticipate, prevent it, or eventually, or in case, manage it. How? Implementing, in case, a recovery plan, which should be already studied in advance. For example, if what can happen with this day, as I said earlier, a component can fail, so I need to have already at site the backup. I don't have wind. Okay, so let's book the whole team for the whole day, for the whole week, so that once we manage all these three comms, commissioning, communication, complexity, we can achieve the commercial operation. So, Kim, I'm done. I thank you. So the next slide is thank you. That's all, folks. And thank you. I hope you enjoyed this presentation.
Thank you so much, Simone. That was very insightful, and we really appreciate you taking time. And also, I know you were squeezed in terms of time, and thank you for sticking to the 20 minutes. To our audience, we've come to the end of the presentations, and thanks for sticking with us up until now. We are running a bit over time because of our delayed start, but we are going to go straight into the Q&A session, and I'm going to hand over to Nivesh. Over to you, Nivesh.
Thank you, Ntombi, and thank you to the speakers for that insightful presentations. Kim, can I ask that we drop the presentation, and can I ask the speakers to put on their camera so we can engage in terms of the questions? My panelists have been very efficient today, so they've answered a number of the questions through the chat function, so thank you for that. It's going to save us some time. Given that we are running out of time, or we've run out of time already, please can I ask the speakers to keep your answers short and to the point so we can get through as many of the questions that we can. We have a number of questions from Tuana, and I think we should have told Tuana that the first two questions are free and thereafter we start charging. But anyway, let's get to these questions. Dylan, I'm going to start with you. There's a number of questions for you. The first one is there a repository you can suggest which provides industry price benchmarks for grid-tied solar and grid-tied solar with battery installations?
No, I don't know of anywhere where that is, publicly advertised. And I'd say it's because it'll get outdated relatively quickly. Battery pricing is coming down fast. Module pricing did come down fast, but then it does get influenced by market events. End of last year, there was a glass shortage in China. Pricing went up, and then it stabilizes in a few months' time again. Similar to the oil price, it's influenced by raw material availability. So, in short, no.
Thanks, Dylan. I think the lenders would have a better handle on this, so a number of them do put it up on their websites as well. The second question for you, Dylan, is for an EPC, what do you recommend as the best way to include an initial overlooked critical part of the project during the implementation phase?
Can you say that again? What is the best?
What is the best way to include an initially overlooked critical part of the project when you're already in implementation phase? So you've overlooked it in planning. It's a critical part of the project. How do you now include it when you are implementing?
Okay, first thing, you start to panic because you've got liquidated damages coming your direction. No, look, I think one has to look. That shouldn't happen. You know, with a professional EPC, one knows what to pre-plan for. There are always some anomalies, but there should be various checklists in place which make sure that you cover all bases. If something comes about, you've got to, you know, I think I've seen applications or projects where in Namibia recently where the site hit landmines, funnily enough, limpet mines were found in the trenches and everything had to be put on hold. So when things like that happen, you know, you either have to immediately put your hand up, claim for a force majeure event, and then plan around it and reschedule. Yeah, that's the best I can say. You pull the handbrake up, see how you can integrate it, see how it affects your timelines, and then push play.
Thanks.
Nivesh, can I add just very briefly to that? Is that, well, I mean, for a critical element of the project to be missed up until implementation phase, I think is highly unlikely, because you've got multiple heads looking at the thing, including the lender's technical advisor, who's going to be looking at it extremely carefully. So I think it's unlikely. But if there is such a thing, then the immediate correction would be a variation under the contract.
Thanks for that, Matt. Dylan, your next question is with regards to quality at the design phase. What are the key best practice points for quality during design phase?
I think we look very hard at the quality of the major components. They are obviously all an Achilles heel to the project success. And there are intense discussions which take place with manufacturers. There are factory visits that take place on a regular basis by our procurement team. We do look at the warranties, although as Matt mentioned, nothing's bulletproof in that regard. And really, I think a lot of it's to do with a relationship and historical track record of technologies. We are not going to be the guinea pig for any newbie, unfortunately. We'd rather ensure that we use a product that's been tried and tested, and because of that, you'll find that a lot of tenders call for minimum requirements of installed capacity in order to ensure that other people have been the guinea pigs and their project's not going to be the guinea pig. And then if you filter it down to balance of equipment, the lenders as well as the IPP's technical advisors often define specifications in terms of even cabling. One of the challenges, however, is that if you go overboard on those specifications, like Isak alluded to, is that sometimes they're not even available in the country, but then you still have to meet local content obligations. So it becomes a bit of a conundrum that you have to, you know, pull a rabbit out of a hat and fix. But in general, the planning around the right technologies at the design phase is all to do with product choice.
Sure, good. And then the last question for you, Dylan, is the impacts of COVID-19. As an EPC, have you seen any of these impacts impact your business, and which ones would you seriously consider as part of business as usual going forward?
So there was definitely an impact during the hard lockdown. We stopped construction on site for about a 2-month period, and that had a knock-on effect on our value chain and ended up putting in a force majeure claim for 90 days. Thankfully, those claims were honored, but it did cost us, because although you are getting a relief on the timeline on your project, you still have people on payroll, and you have to deal with that. In terms of mitigation going forward, I think going forward, standard practice will be the normal rules around COVID and social distancing as best possible, wearing masks, sanitizing, and that's all kind of standard now on site as per entering a shopping center. It's the same when you enter any construction site. What's good is that test kits are available. So we've recently procured 100 tests where we can within 10 minutes identify if someone with symptoms has actually got COVID or not. And if our test kits come up positive, we then send them for formal testing, and that alleviates the concern and what's transpired subsequent to COVID happening, where people put their hand up with the sniffles and you know, cry foul because now they think they've got COVID, and then they take 2 weeks off, which, you know, isn't productive at all. So these test kits are really handy.
Good. Thank you for that, Dylan. There's two questions for you. The first one is, can you kindly share how you have dealt with equipment or plant not meeting the performance specification during the commissioning stage?
Okay, Nivesh and Tauna, thankfully, I have not had to enter into any contractual dispute resolution kind of situations with suppliers of equipment. In most of the cases, you call upon the contractor to come to site to come and fix the defect or the problem that showed itself on the product during the commissioning phase. So yes, that's the easiest way to do it, is to actually for the manufacturer or the supplier of the equipment to just come to site to come and fix whatever has to be fixed. For example, what I mentioned earlier, a transformer oil leak, the guys come to site and they either come and replace a part or they just install new gaskets or whatever. I've been involved in some much more serious problems, which I don't want to delve into the details because that's going to keep us busy the rest of the afternoon and early evening. But yeah, no, the supplier or manufacturer has to be part of the process all the way. Otherwise, and that's why also, as Dylan mentioned, product selection, it's also about supplier or manufacturer selection together with the product that you select. It needs to be a partnership in the end.
Good, thank you. And with regards to operation and maintenance, what operation and maintenance measures or issues do you recommend need better consideration during the design and implementation phase?
Okay, that one I think isn't too difficult. I would say maintenance-free or almost maintenance-free designs. What I mean by that is people tend to, when they, or developers at least, when they tend to do their financial modeling, they have in their model, they've got 100% or almost like a Chinese wall between the CapEx phase of the project and the OpEx phase of the project. But it is often possible to optimize and to integrate those two so that, for example, I'm going to plug numbers out of the air. You could perhaps spend 5 million rand or 3 million rand more CapEx, but you could be saving 7 or 10 million rand through the operational phase by just selecting maintenance-free switchgear, for example, your 33 kV switchgear. In other words, if you install something which doesn't have to be maintained for a 15 or a 20-year period during the project, then rather spend the extra couple of bucks and you don't have to ever touch that equipment. So from a design perspective, I would suggest that you should focus on as low as possible maintenance requirements. But like I mentioned in the beginning, I think developers and the guys that do the financial modeling should strongly start to consider to integrate those two actually to play off the CapEx versus the OpEx savings that you could, CapEx spend versus OpEx savings over the life of a project.
But I think, if I may add,
please do.
People need to join on the 25th of next month to find out more information about that.
Thank you for that selling point. Thanks for that. There's another question. Matt, I'm going to come to you for this question. In the case that your spares fail, what is the process and how do you source them?
Okay, so typically what you would find is that the contract provides for a minimum schedule or capacity of spare parts that would cover typically the defects notification period, and then that the O&M contract would cover the spare part requirements, so that you know, and it depends on what the agreement stipulates, whether it's going to be in that instance it's the owner or the operator's obligation to source and procure spare parts, but that will have been covered off in the contract.
Thanks, Matt.
I also want to add to that, if I may. Often the spares, and it depends on what kind of spares it is, consumables versus specific equipment. But often if the piece of equipment would fail during the warranty, then naturally the O&M contractor would use the spare, which is kept on site, to replace the failed part, and then the EPC contractor who is responsible for the warranty must replace that spare again.
Yes, yes, exactly right.
Good. Thank you. Simone, I see that the same question is posed to you. Do you have something to add to that, or are you happy with that answer?
Just to add, basically, you don't have 4 spare tires, 4 spare tires in your car. No, you have 1. And if you hear some vibration, or if someday you see a bit flat, what you do? You go to the maintenance. So similarly, in our plants, no, we have all the warnings that we detect in the Scada, and this can be signs that something is going to fail, or we have also the preventive maintenance. No, that is done over a certain time of period in order to prevent the equipment to fail. So let's say failure will always happen, but what we can do is try to minimize, have the most, let's say, the silliest thing. No, we cannot stop one farm because an O-ring is missing or because a bolt is missing. Obviously, if it's like the car, if your tire goes flat, you can replace it. If the engine goes kaput, it's a bigger problem, no? And what you do is to maintain, no? Change the oil, regularly checks it, and similarly we have to do with our plants in order to ensure the maximum operation, the maximum revenues, and prevent any issues during the operation. Only that.
Good, thank you. Ntombi, I think I've covered all of the questions. Thank you to everyone for the comments on the great presentations by the speakers. Ntombi, if you don't mind, I can go straight into closing remarks.
Nivesh?
Yes.
Oh, sorry, Isak. Can I say one quick thing perhaps about the serial defect topic as well? There was a question about that, and I know Matt answered it. From a contractor point of view, we must also remember that serial defects, we understand fully the purpose of the concept of a serial defect, but often serial defects are in some cases very difficult to apply. For example, if you've got 2 main power transformers in your substation and the first one fails, you cannot now expect the contractor to replace the other one as well, simply because the first one has failed. So we need to somehow, in the wording of the EPC contract, find a way to get around those kinds of low quantity items to actually still have a serial defect clause, but to make sure that the poor contractor doesn't close his doors because they have to replace 2 power transformers.
It's like you make a very valid point, and how we typically deal with that under the contracts is to make sure that those particular kinds of items are excluded. So, you know, a serial defect is really to cover, you know, equipment items that are, you know, more than just a couple. We're looking at, for example, 300,000 solar PV modules across our solar farm. It's that kind of equipment, and there is wording and language that we implement to make sure that it's properly implemented in respect of what it's designed or meant to do.
Good. Thanks, Isak and Matt. Ntombi, you happy for me to close out?
Yes, I'm happy for you to close up, Nivesh. Thanks.
Thank you very much. So just a quick thank you to the speakers. I think you guys have covered all of the important key points that would have been raised and have been raised. So thank you for that. It was quite an insightful session, even for myself. Just a couple of points more. This has been our 6th out of 7 webinars in this series of developing developers. We've had excellent participation across all 6 of them, with more than 3,000 participants in those 6 sessions. We've had 25 industry leaders, experts in the field who have provided relevant presentations on a number of topics across those 6 webinars. We've also had a number of sponsors who have allowed for us to offer this free of charge to participants listening into the program. We look forward to the next session, and this is, as Dylan said, focused on the operation and maintenance of renewable energy projects. And this is scheduled for next month on the 25th of March. So please do register and join us for that session. I'd also like to inform you to watch out for the next series of webinars that we'll be launching. So together with SAWEA, we'll be launching developing local supply chains. And we'll be talking about local content and localization, industrialization, those kinds of topics, and how to create more supply chains here in South Africa. And then SAPVIA is also going to be launching a webinar series called Driving Distributed Generation. And that one we're going to be focusing on commercial and industrial projects mostly. And then a quick thank you to a number of people. Firstly, to the SAPVIA and SAWEA staff, Kim, Marilise, Lindo. It's these guys who bring these sessions to life. So thank you guys for all of the work that you do at the background. Thank you to Zani, who's our service provider in assisting with the setup, the comms and the marketing of these webinar sessions. Thank you to the series sponsors, Mainstream Renewable Power and Juvi Renewable Energies. They've made it a reality for us to bring these topics and these discussions to a platform where we can actually reach hundreds of people at a time. For today's session, Norton Rose Fulbright, Matt has told me that this hour of consultation was for free, but if you need any more advice, he'll be charging you by the hour.
A modest fee.
Our speakers for today, you guys did a phenomenal job. You touched on everything that we needed to get through to the audience, so thank you for that. And last but not least, thank you to the participants for joining. We take a lot of pride, between Ntombi and I, we take a lot of pride in bringing you the content that is relevant and required, and we appreciate the fact that you turn up and you listen, and we still have 100 people at the end of a session, which is really great, so thank you for that. So thank you, everybody. I think with that, Ntombi, we can officially close this session.
Thank you for having us.
Thanks.
Thank you.
Everyone.
Thank you very much, everybody.
Thank you, everybody. Great experience.
Thank you all.